So, very good morning to everybody present in the class. This is your course instructor Khushwant Fatnani. We are doing revision course for JEE and NEET 2020. Let us start our class. And here we go. Before we do, like every class, I request all of you to please join me in a short prayer and meditation session before we begin our class. Everyone, kindly join your hands, close your eyes. One by one, all of us will do a short deep breath session. Count 1. Breathe in and breathe out. Count 2. Breathe in, breathe out. Count 3. Breathe in once again. And breathe out. Let there be a smile on the face. And repeat after me. Dear God, we thank you for this life and all its abundance. I thank you for good health, wealth, and wisdom. I thank you for the support, guidance received from my family, mentors, and my friends. I am thankful for the dream you have set in my heart. I thank you in advance that I have cleared NEET 2020 and JEE 2020 in flying colors and have got admission into one of the best colleges of my dreams. Thank you in advance. Thank you for assisting me. Dear God, thank you once again. Take a deep breath in and a deep breath out. Slowly, with a smile on the face, you may open your eyes. So, dear everyone, let us thus begin with the class for the day. So, we are in a revision session for physics, where we had got introduced to the chapter kinematics and studied some important topics in the same. Let us continue with that. Now, kinematics is one of the chapters, as I had informed earlier. You get very interesting questions from this chapter. One of the topics, which is an intermediate between mathematics and physics, is vectors. Right? Let us have a quick brief insight of it and then go for past year questions which have been asked in relevance with this topic. So first thing, you have quantities defined in two manners, very clear, we know, are called scalar and vectors. we have scalar quantities are the ones in which we have only magnitude, whereas vector quantities are the ones in which we have both magnitude and direction. In order to represent a vector quantity, we have two ways. The representation of a vector is via two ways. The first one is by the use of an arrow. So an arrow can be used to represent a vector, right? Where the direction of the arrow tells me the direction of the vector. I will repeat, an arrow is a diagrammatic form of representing a vector such that the direction of the arrow tells me the direction of the vector, whereas the size of the arrow tells me the magnitude. Right? We had two things in a vector, magnitude and direction. So the direction of the vector tells me about the direction, or the direction of the arrow tells me about the direction of the vector, and the size of the arrow tells me about the direction or the magnitude of that vector. Coming to the next way of representation of a vector, that is, you take an alphabet, put an arrowhead above it, right? And then express it in terms of its components. We express it in terms of its components. Right? So suppose we have, let's say, a point on the XY plane. Let's draw an XY plane. Let's say this is X, this is Y axis, and here is the origin. Now, suppose I have a point somewhere over here. I name it, say, point P, and its coordinates are A comma B, right? So there is a very specific kind of vector which is defined as position vector. Before I talk about position vector, let us finish the definition which we had started with. So the way of representing a vector in the symbolic form is, we have, see here, we have put a alphabet, put an arrowhead above it, then see, there are two parts of it, magnitude and direction. So we'll write here both magnitude and direction. This letter A or this alphabet A is talking about magnitude. This alphabet A with this sign on the head of it is called, or is used to denote, the direction. This is used to denote the direction. And this itself is called as unit vector. This A cap and this sign is called as cap or carets. A more academic way of looking at this is carets. Otherwise, you can call it cap. So I will call A vector is equal to, have a look, this will be called as A vector is equal to magnitude of A, this one, into direction of A, right? Where you call this as A cap or A caret. Then we have this A cap is also called unit vector. Unit vector. Why is it called a unit vector, and what is a unit vector? So the term unit means one. So the magnitude of, this is how you talk about magnitude. You put two bars, right? So the magnitude of unit vector is one, right? So see, a vector has two parts of it. One is magnitude and the other is direction. So if the magnitude is 1, what is more important here? In a unit vector, what is important is direction. So unit vector talks about direction. Yes. Now let us quickly transit to understanding a position vector. So a position vector is a vector which tells me the position of a point, right? And how do we write it? Suppose I denote a position vector by the alphabet R and a cap over it. So if this is the position vector of a point A comma B, then I will represent it as R is equal to A I cap plus B j cap, where A is called as X component of the vector and B is similarly called as Y component of the vector. Component, just try thinking, what is a component? A part of something, right? A part of something is called as component. So here, now we know that for a vector representation, we have written it in terms of its X component times I cap plus its Y component times J cap. So this I cap and J cap, what are they? Let us see. So here we have, suppose we have 3 axes, X, Y and Z. Let me denote them here in this format, X, Y and Z. So the unit vector along, mark my words, unit vector along X axis is I cap, unit vector along Y axis is J cap, unit vector along Z axis is K cap. So when I'm representing a vector in the format R is equal to AI cap plus BJ cap plus CK cap. What would it mean? It would mean that in the direction of X, the component is A. In the direction of Y, the component is B. In the direction of Z, the component is C. Right? Component is C in direction of Z, component is B in direction of Y, and component is A in direction of X. So basically, I split the vector in the terms of its components, and these are also called as, these will be either called as components or projections of a vector, or projections of a vector, right? Now projection along, right, along respective axis. So this is along X axis, this is along Y axis, this is projection along Z axis, along different axes, right? Now after you understand this, we have something called as addition and subtraction of vectors. Addition, subtraction and multiplication of vectors. Before we understand these three, it's important to see how do you find out angle between vectors. So give the heading angle between vectors. Very simple. In order to find out angle between two vectors, they have to be either coterminous. Condition is either they have to be coterminous or they have to be co-initial. Right. So what does coterminous mean? Coterminous. Co is same, terminus is ending. So this is how a vector starts. Have a look. I will draw it here. So if this is representation of a vector, this is called head and this is called tail of a vector. Right? This is called tail, whereas this one is head. head and tail. Now, when two vectors are oriented in this manner, have a look. That is their heads coming together. It's called a combination of coterminous vectors. So now if you have a coterminous set of vectors and you take angle between them, this angle is called as the angle between them, right? Or you have to either bring them, just have a look, say this was, one of them was vector A while the other of them was vector B, right? Now I will take them and just put them on the, in a manner that their tails will coincide. Have a look. How? So I'll take this B, bring it over here, right? This is vector B. Similarly, the vector A, I'll bring it over here, right? So see, in order to measure the angle between the vectors, I have either made their heads coincide or made their tails coincide. Both will give me the same angle. And this is how angle between the vectors is measured. So giving you all a minute, write all of this I have written on the board and we'll quickly restart, right? Take a minute or two. I'll one by one scroll through each screen. Once you are done, raise your hand after the second sheet, right? For this sheet, just jot it down. I'm waiting. For the second sheet, I'll go, wait, write, and then I'll move ahead, right? Yes, class. Get going. Start taking the notes. Very important, not only just take the notes, try to absorb very properly all that I have said. If there is any query, we'll discuss it later. Let's first go through it. Yes, get going, class. Start taking your notes. Class, make sure here when you're writing A, do name this A as magnitude, right? Transiting to page 2, kindly jot this down so that we can move ahead. Once you are done jotting down and understanding, please raise your hand, right? So class, please be quick. As soon as you're done writing this page, please raise your hand, right? Thank you. Right. So let us move ahead. Now, talking about addition of vectors. When two vectors are to be added, we use, thank you class, you can bring your hands down. So when two vectors are to be added, we use a law called as parallelogram of vector law addition. Very simple, right? Parallelogram says that in order to add two vectors, step one, make them co-initial. Make vectors co-initial. That means they should start from the same point. Make vectors co-initial. Do the same. We have two vectors, let's say A and B. So I'll draw them and make them co-initial. So this is one vector, and let's say this is another vector. So I'll make them co-initial. Once this is done, I will assume that the vectors are adjacent sides of, make a parallelogram. So basically make a parallelogram and assume that the vectors are adjacent sides of that parallelogram. So suppose here is how I'll make the parallelogram. Make a parallelogram with vectors as its adjacent sides, right? Now, third step is their resultant. Their resultant. What is resultant? Resultant is the sum of the vector, or let us say the diagonal of the, or in fact the co-initial diagonal. The co-initial diagonal represents the resultant. Represents the sum or resultant of vectors. This is what parallelogram law is about, right? So we have A and this is B. Now, suppose this is the angle between them, theta, right? So here is how will their diagonal or the resultant look like, this way. This green color arrow is telling me the resultant of A and B. Let us represent it by a letter R. So we'll write R is equal to A plus B. You write this is R given as A plus B. Correct? Now we write the magnitude of R. Put two bars. Magnitude of R is equal to magnitude of A plus B. And this is given as, you all must be aware, as under root of A square plus B square plus 2AB cos theta. Correct? So this was a quick introduction to what parallelogram law of vector addition is and how do you write the resultant of two vectors in formula form, where theta is the angle between two vectors. I will repeat, theta is the angle between two vectors. There is one more formula which tells me what is the direction of the vector, right? The resultant vector, direction of resultant R. direction of resultant R. It is given by the tan of this angle which the resultant is making with one of the vectors. See, this R is making an angle phi with A, so I will write tan phi is given as, right, tan phi will be given as B sine theta upon A plus B cos theta, where theta is the angle between A and B. And what are these values? This just A, just B. So here A and B are the magnitudes of the vectors A and vectors B. Magnitudes of A and B. And theta I've already told is the angle. Remember, theta is the angle which is measured only when vectors are co-initial or co-terminus. So angle between vectors, right? So quickly jot these two formulas with you so that we can move ahead with the application and questions from past year from this topic. Yes, class, get going. Right? Once you are done understanding this, we'll go to the next part. Right. So let's see how do we talk about one of the another important aspects, that is subtraction of vectors. Subtraction of vectors. In order to subtract two vectors, right? In order to subtract two vectors, again, what do? You take two co-initial vectors. You take two co-initial vectors, or you make them co-initial, whatever. Make the vectors co-initial. So suppose you have a vector this way, right? And there is one more vector in this direction, something like this, right? You have two vectors. Bring them together and place them in a manner such that they become co-initial. So you'll have a vector. This is 1 and this is 2, right? See, we have brought them and made them co-initial. This was step number 1, right? Then the next step, part 2, is to draw or complete the triangle. Draw the third side of the triangle. Draw the third side of the triangle. See, how do you draw the third side? So suppose this is vector A, this is vector B, right? Now, your third side will be, suppose we draw a third side in this manner, right? We can have also another way of drawing it. How? Have a look. This way. This is A. And let's say this is B, right? We have kept A and B. Then instead of taking it towards B, I can keep the head of the third side towards A. See? Right? Now, what is the difference between them? This is A and this is B, right? So now the third side is actually representing the difference between the two vectors. I'll repeat, the third side is representing the difference between the two vectors. Suppose I name this side as C, right? So I will call this C as B minus A. Whereas here I will call this, let's say I name it as D. So this D will be called as A minus B. How to remember it, right? So the third vector, that is the vector C, or the difference between them, if I call this as vector D, small d, so I will call it as difference between head and tail. So I will call it as the vector at the head minus vector at its tail. See, I'll tell you how. See, for this green color vector in the first figure, head of green, I'm talking about the head of green, is with B. Therefore, see, I've written here B. Then the tail of green is with A. So I've written A. So basically, all you have to do is simply head minus tail. Head minus tail. See here, for this green vector, the head is lying along with A. Therefore, I've written A. Then the tail of the green vector is lying with B. So I've written A minus B. Basically, head vector at the head minus vector at the tail is giving you the subtraction of two vectors, right? Or the difference of two vectors. This was the step number 3. Right, class. Take a minute, jot this down, then we'll move ahead. Once you're done writing, raise your hand. All right. So I can see many are still writing. Class, as soon as you're done, please raise your hand. Gitika, Harsh, Mahila, Rutuja, Siddharth, so that I'll know that you are done with writing the lecture. Do mention here where is the head of green and where is the tail of green in both figures. Will make matters clearer, right? All right. Now that you are done writing this, let us move to the next part. So you have seen here now addition and subtraction of two vectors, right? One of the very important facts, if I have a vector formed from the resultant, let's say R, right? So when I talk about a vector R, which is made from A and B, right? Which is made from A and B, right? So this vector, right, which is made from A and B is given as its constraints or its limits are given in this manner. Have a look. R vector's magnitude, right? Its maximum value is the sum of magnitudes of A and B, right? And its minimum value is the difference of magnitudes of A and B. Right? I hope it's clear with everyone. When we are talking about two vectors, when we are talking about two vectors, their resultant's magnitude lies between their individual magnitude sum or their individual magnitudes difference. Please take this with you. Another important note, that magnitude of a vector is always positive because it's representing the size of the arrow. You remember I told that the size tells you about the magnitude, and therefore the magnitude of the vector is always positive because size of any arrow cannot be negative, right? Size is always a positive quantity, is always positive. So because it's a size, because it is size of the arrow, right? In fact, it is not a very rational reason to speak, but then yeah, in just to make sure that you all are clear with the meaning and you don't forget it, we have taken this one, right? Now, coming to the understanding of product of two vectors, right? Product of two vectors, right? So give a heading, product. There are two types of products you all must be aware with. One is called scalar, while the other is called vector. So everyone, those who have finished writing, you may bring your hands down. Thank you, right? All right. So we have scalar product is represented by a dot, and it's also called as a dot product, A dot B. Whereas a vector product is represented by a cross and is also called a cross product. You write it as A cross B, right? Here, scalar product, as the name suggests, is scalar. That means it only has a magnitude, and the magnitude is given by AB cos theta, right? Here, vector product, as the name suggests, it's a vector quantity, and its magnitude and direction are given in this manner. See, its magnitude is AB sine theta, and its direction is represented by n cap. What is n cap? So say we have a plane where two vectors are lying. Let's say this is A and this is B. We have a plane where two vectors are lying. We have one vector is A and the other vector is B. When I talk about vector A cross B, vector A cross B, this A cross B is a vector which is perpendicular to both A and B. Vector A is perpendicular to both A and B, right? Now we have therefore n given as A cross B whole by, see from here I am writing it, A cross B whole by AB sine theta, right? Very evident from the formula written above that how will you give n cap? N cap is basically the unit vector along this direction. Mark this, I'm saying that n cap is unit vector in a direction is unit vector in a direction perpendicular to, again, both A and B. Now there can be two ways. Perpendicular can be either upwards or it can be downwards. How do you decide this? You decide this by understanding screw rule, or you can call it as right hand thumb rule. So there are two rules, right? Now what you do, all I'm doing is, for a minute, I'll stop the screen share. Have a look at my hands, right? And suppose I have two vectors. So this is an understanding. Those students who do not understand this well, when we'll be covering class 12 syllabus, where we'll be reading about the cross product of vectors when in the chapter magnetic effects of current, right? Or when we'll be reading how a charged particle behaves in a magnetic field. I will repeat, how a charged particle Q behaves in a magnetic field B. When we talk about it, many students get baffled because they do not understand this concept clearly. Once this concept is clear, your understanding or visualization of charged particles in a magnetic field will become crystal clear. Have a look. I have two vectors, right, represented by different color pens, red and black. Let's say red is A, black is B, right? Now, from red to black, if I want to take a cross product, I will call this as A cross B, right? R cross B. You can take it as A cross B. See what I'll do? I take my right hand. Maybe you can do it at your own home. You'll get a hang of it. Right hand make your right hand fingers curl from A till B. See what I'm doing? The right hand is making its fingers curl from A to B, A to B, right? See where your thumb is pointing. The thumb is pointing in the upward direction, right? A to B, A cross B. So this is how the direction is decided for the cross product. I will repeat, the right hand thumb rule is used to denote or used to understand what will be the direction of cross product. We take two vectors, this is A, this is B. We go from A to B. So take your fingers, curl in the direction A to B. See where your thumb goes. In the direction in which the thumb goes, let's say this pencil is in the direction, in the upward direction. So I will call this is the direction of A cross B. Do it the other way around. Now I want to find out the direction of B cross A. See, take your right hand, right palm, curl it from B to A. This was black or B. See, B to A, B to A, right? Keep it horizontal now. B to A. See, B to A. So now the thumb is pointing in the downward direction. See, when I do it from B to A, the thumb is pointing in the downward direction. See, B to A. This is B, this is A, right? So what does this imply? Let us see. Here, when you go from A to B, it was in the top direction, whereas when you went from B to A, when you went from B to A, so I'll write it even clearly, drawing it with orange. B to A, it went in the downward direction, right? So this implies one more aspect about cross product, and that aspect is A cross B. A cross B is nothing but minus of B cross A. A cross B is nothing but minus of B cross A, right? Now, the way we represented cross product and talked about its properties, similarly, for dot product, the concept is very clear, right? One of the usages of cross product or vector products is to find this. That is the vector n cap, which is perpendicular to both A and B. Remember this, right? It's a very frequently asked question in NEET exam. Now, let's say we take here and talk about cos theta. See, I'll write about cos theta. So cos theta will be given as A dot B upon AB, right? Where A and B are individually magnitudes of A and B, right? And of course, here we have the dot product of the two. So what is the general use of dot product or scalar product? It is used to find out the angle between two vectors. It is used to find angle between two vectors, right? So everyone, I hope everyone is done writing. Please do it the same in case not yet. Yes. Correct. I hope all are done. So now let's see some questions from the past years which have been based on the understanding of vectors, right? Okay. So here, this is one of the questions from JEE 2019, right? Everyone concentrate on the question. Question says the position vector of a particle R is changing with time according to the relation given by 15 t square I cap plus 4 minus 20 j cap. t, 4 minus 20 t square, 4 minus 20 t square j cap, right? Now you're being told what is the magnitude of its acceleration. See, it's asked what is the magnitude of its acceleration, right, at t is equal to 1. Very, very simple question. See here, when you are given with position vector, you are given with its components. See, every position vector has two components. Do you remember? See here, when we talked about position vectors, see here, every position vector has two components. This first one is x, second one is y. See here, this is x component A and this is y component B. In our case, A comma B was a constant point, right? It had some constant value, but the same is not true in this scenario. Here, in the given scenario, both x and y component are variable. Why variable? See, remember, yesterday we had understood the definition of variable and constant. Any quantity which is changing is called variable. Any quantity which is changing is called a variable. So here, the x component, let us say Rx, right? Or you can also call it as x, simply x. For R is 15t square, right? And the y component is, or y is given as 4 minus 20t square. Correct? What are you being told? You're being told to find out acceleration. Now, yesterday we had read that, try recalling, if you have x, when you differentiate it with respect to t, you get velocity v. And when you differentiate velocity with respect to time, you get acceleration. Until yesterday, these quantities were only along one direction because we were talking about one dimensional motion. When we start talking about 2 or 3 dimensional motion, there is no longer one direction, rather two directions. So now onwards, R will have an x component and R will have a y component, right? But it's very easy to understand because the same formula will hold, just that it will hold for a particular component. See what I'm saying? The same formula will hold, but just that it will hold for a separate component. So I'll write same formula holds for the components. What does this imply? See here what I'm writing. I'm writing, therefore V will be given as dx by dt, right? That is the differentiation of x component of R times of I cap plus differentiation of y component of R times of j cap. As simple as that, right? Similarly here, acceleration will be equal to dv x by dt. Let us call this x component as vx, right? So dvx by dt I cap plus dvy by dt j cap, where let us call this as vy or y component of velocity, right? So what will happen here? We have Rx and Ry quickly differentiated with respect to time and get the x component and y components of velocity. See here, we have d by dx of x component, that is 15t square, will give me 30t. This is vx, right? So we'll have ax is equal to dvx by dt given as 30, correct? In a similar manner, you will have vy is equal to dry by dt, which is d by dt of 4 minus 20t square, right? Which is equal to minus 40t, correct? Similarly, ay will be equal to d by dt of vy, which is equal to minus 40, correct? What did I do? I have differentiated x component and y component of a of r twice. First one to get velocity, second one to get acceleration, correct? All you get here is the final answer, that is, have a look. See here, the final answer yields me X component of acceleration is 30, right? And Y component of acceleration is 40. What? The unit are meter per second square, right? So you'll have here A will be given as AX I cap plus AY J cap, right? Any vector X component and Y component. This we got as 30 I cap, right? AY came out to be minus 40. So we'll write minus 40 J cap, correct? So this will give you 30 I cap minus 40 J cap. What are we being told? Just revert back to the question. It says that find out the magnitude of acceleration at t is equal to 1. Have a very close observation. Here acceleration is not depending upon time, and therefore at all times, acceleration will be constant and equal to 30 I cap minus 40 J cap. This is a constant acceleration. Why constant? Why constant? Because it is not depending upon time. It is not depending on time. Very important. Some students understand it a little later, but if you have understood it now, excellent, right? So here acceleration is not dependent on time, and therefore it is constant, right? Any constant quantity is not changing with time, right? So here this is what is acceleration, right? So we have been asked to find out the magnitude. How will you find the magnitude? So in terms of components, if a vector is given, this is how we find the magnitude. You have you have y axis and x axis, y and x axis. Here is your vector, right? And these are its components. Suppose this is theta, then this is the, and this is our vector, then this is called the x component, which we had just written as a some time back, right? You can also write in terms of theta as r cos theta, whereas this y component can be written as r sin theta. You know, some students try to mug up that this is r cos theta x component and this is r sin theta y component. Please do not mug up. Understand this, that since this is theta, you are getting this as r cos theta. If suppose I take an angle over here, the angle with the y-axis, and call this as alpha, right? Then no longer will I be able to call this as r cos alpha. Rather, the x component will be called as r sin alpha, and the y component will be now called as r cos alpha. See, this is a very important observation you all should keep in mind. Now, the vector r is represented as rx I cap plus ry j cap, where I can also write this as r cos theta I cap plus r sin theta j cap, where what is r? I'll talk about it. So here r vector can also be written as r sin alpha I cap plus r cos alpha j cap. Very important. Where what is this r? What is r? R is the magnitude of the vector r. Right? Now, in terms of its magnitude, it's given as, see here, rx square plus ry square plus 2 rx cos theta. What is the cos of angle between them? This angle. Or what is the angle between two components? See here, this is one component, this is next component. This is called as y component, this is called as x component. What is the angle between them? See, what is the angle between them? 90, right? So cos 90 is 0. So this is just for the sake of understanding. Otherwise, you will always write that vector in terms of its component components is given by under root of Rx square plus Ry square. Rx square plus Ry square. Please jot this down with you. So this is how you get the acceleration in terms of its components, and then you take its magnitude under root of 30 square plus, mind here we have minus 40, so when you take minus 40 square it will also give you the same as 40 square, so the sign becomes irrelevant and you get the answer as 50 meter per second square. Class, please jot this down with you. I'll open the pages one by one. Any queries, let me know, right? This was page number 1. Try solving the question by your own self, although I am solving in front of you. But first your attempt should be try solving it by yourself, right? Every year from vectors chapter, there are a good number of questions asked in both examinations. So make sure that you do not skip out on this, right? Right. So here is the next page. Class, quickly jot this down and also write here a small heading with you where we read a short concept, and the concept is vector in terms of its magnitude, or vector's magnitude in terms of its components. Vector in terms of its components. Do make sure you write this heading in your lecture copy and then make your notes, right? And this is the formula for magnitude of a vector. Magnitude of a vector in terms of its components. In terms of its components. Right. Class, so let us move to the next question. You have next question given as, it's a question from NEET 2013. Kindly, in fact, let us take NEET 2017 question first. NEET 2017. The question says the x and y coordinates, remember, listen carefully, the x and y coordinates of any particle at any time are given as x is equal to 5t minus 2t square and y is equal to 10t, right? Where x and y are in meters and time is in seconds. Very simple, right? Time is in seconds. Then you're being told the acceleration of the particle. See, again the same kind of question. Acceleration of the particle. Acceleration of the particle at t is equal to 20. Class, I'll try to tell you how NEET and JEE borrow questions from each other, at least in the terms of format. See here, same question, same kind of question asked in terms of R, right? In JEE 2019 was a question here in NEET 2017. So both papers, be it NEET or JEE, borrow their questions from each other. That is why, remember, in one of the classes I had informed you all that on the National Testing Agency's website, right, the agency which conducts these exams, free of cost mock papers are available, right? So please make sure you solve all the mock papers of the last years as much possible at your end, be it JEE or NEET. If you're a NEET candidate, Do solve JEE papers. If you're a JEE candidate, do solve NEET papers also, right? The mock papers, please solve them. If you haven't still started, make a habit of solving at least one paper a day. If you can solve just one part, let's say take up physics, spend 1 hour on it every day, because this is the amount of time that you're going to have in the exam also, right? In the exam also, on average you will have 1 hour for physics. So take your paper, solve for 1 hour, the every day invest in it. This will be a very beautiful investment, which will make you proud of yourself, that thank God that day I had listened to sir, and for every day in the month I have solved one paper, and see how strong I am now, and so see how amazing rank I have got in the paper, right? Your concepts will be very clear. Please start off from today itself if you haven't yet started. Okay, continuing. Acceleration of the particle at time t is equal to 2, right? So let us take this question or answer from Atul. So I'll put on the mic, just a minute, Atul. Yeah. So yeah, Atul, I've unmuted you. Try answering this question. How will you go about it? Yes.
So we will first find out the velocity by
Yes.
differentiating the x component.
Let us do it. D by dt of x, right? So this will give me d by dt of how much? 5t
5t minus 2
2t
t
square,
square,
correct? After which I will get 5 minus how much?
4t.
4t, absolutely correct, will give me vx. All right, how do you calculate ax?
Then we will differentiate it once again. The answer will be minus 4.
Absolutely correct. So
Ax will be minus
it again in order to get differentiation of 5 minus 4t, which will yield 0 minus 4 or minus 4, correct? Right? So we have
4. Yes, sir.
acceleration x component given as minus 4, right? Now we have this as the component here. This is x component of velocity, this is x component of acceleration. Absolutely correct. Now what about the next part? So yeah, we have
Uh,
Py is given as dy by dt, right?
yes, sir.
Right. So what will it
10,
be? D by dt of
10,
10t,
10t.
which is 10. Absolutely correct. So 10 is Vy, right? So what will Ay be? Ay will be dy d Vy by dt, right? Differentiation of y component of velocity will give me y component of acceleration, right? So differentiation of
Yes,
a
sir.
constant, how much is it, Atul? Differentiation of a constant is
0,
0. Absolutely correct. So
0.
differentiation of 10 will be 0. Absolutely correct, Atul. So what have we got? We have got that Ay is equal to 0, right? So we will write here, let's say I write it on another page. We have got Ax is equal to minus 4, Ax is equal to minus 4, and Ay is equal to 0. So we will have A is given as Ax I cap plus Ay j cap. So we will have A is equal to minus 4 I cap, right? Plus 0
Yes, sir.
j cap. This does not make any sense. So we will have, therefore A is equal to minus 4 I cap. Am I correct, Atul? Please verify. Have a look. What
Yes, sir.
all we did, is it correct?
Yes, yes, sir.
All right. Thank you, Atul. Thank you. Yeah. So, yes, I believe there is somebody with a query. Yes, Harsh. Yes, Harsh. Just a minute. I'll unmute you. You may ask your doubt. Just a minute. Yes, Harsh. Let me know. So, there is some message. Okay. So, Siddharth, in case internet is not working properly at your end, you may do one thing. You can, yes, Siddharth, you can do one thing, that in case right now you miss out on something, I'll again repeat for everybody's convenience. This entire lecture series will be available. Okay. Okay. All right. So yeah, class, 1 minute. I have some messages coming from you all. Just having a look at it. All right. So just 1 minute, class. So class, there are some students who have any kind of network connections or issues like that. So for all of you, as I had suggested, that you all can go with like try to come to the class in between in case somewhere you miss out on something. So all of these lectures are being recorded. They'll be uploaded on the YouTube channel Physics with Fatnani, where you can like and subscribe to it so that whenever we have a new like video upload, you will get the notification, right? So please do that so that whenever, in case you miss out on something, just you can log on again to that YouTube channel and watch that video for that particular small section where you miss out, right? So in case suppose you have a you have some issue coming up right now, you can also try logging off and logging in again. Even that sometimes resolves the issue, right? Try doing that. I'm here. I'll take you in. No worries. All right. So let's re-begin. Okay. Just a minute, class. Right. I think Shivani had been giving the answers. Yes, yes, Shivani, you're absolutely correct. So actually, you were asked in the question that what is the acceleration? In general, acceleration was asked, right? So whenever acceleration is asked, you always take acceleration as a vector quantity, and all the vector quantities will be expressed unless otherwise specified in this format only, right? So you were asked what is the acceleration, so you will take acceleration is equal to minus 4 I cap, right? So this is how the point is, right? So class, let us take one more question, right? This question is again from one of the NEET examinations, right? And it is again a very probable kind of questions. I will give it 2 stars. This question is from CBSE PMT 2010. This question is from AI PMT, right, or CBSE PMT 2010. The question says you have a particle with initial velocity is given as, or u is given as 3 I cap plus 4 j cap, right? And you're being told that it has acceleration a given as zero point 0.4 I cap plus zero point 0.4 I cap plus zero point 0.3 j cap, right? Its speed after 10 seconds is, its speed, see, remember what you're being asked. You're being asked about the speed. Its speed after 10 seconds is, right? You're being asked about the speed. How do you do such a question? First of all, select what is ux. This is ux. Select what is uy. This is uy. Select what is ax. You have ax. This is ay. Try seeing, in order to find out the speed, right? We took this formula here. Why did we take this formula in first go? Why did we write v is equal to dx by dt and not v is equal to u plus at? Why? Yesterday we had discussed, right? Thanks to Manjunath that he asked the question that, sir, why are we not using this kind of formula here? Because here this acceleration was not constant. It may or may not have been constant. We don't know, right? Perhaps it was constant, perhaps it was not constant, right? So, for such cases, we assume the general formula. We assume the general formula that A is equal to dV by dt, which works for both constant as well as variable acceleration, right? So here, what are we going to do is, for such a question, see, we can clearly see that both x component as well as y component of acceleration are constant. See, this is zero point 0.4 and this is zero point 0.3. Constant means no dependence on time. Remember, constant means no dependence on time. So very simple, we know the formula for speed with time. See, we have three relations: v is equal to u plus at, s is equal to ut plus half at square, then we have v square is equal to u square plus 2as. So now only there is one relation which connects speed and time. See which one? The first one, right? On an obvious note, v and t. Only one formula which has both v and t. That is formula number 1. So we'll take the first formula, right, for both x component and y component. We'll have vx is equal to ux plus axt, vy is equal to uy plus ayt. As soon as you write this, you're almost done with the answer. See what you'll write? You'll write here vx. What is the value of ux? See, 3. So you'll write 3 plus ax. What is the value of ax? See, zero point 0.4. How much time do we have? 10 seconds into 10, right? You'll get the answer 3 plus 4, that is 7 meter per second. This is the x component of the velocity after 10 seconds, right? Then see the second part here. Here we have vy is equal to uy. See, what's the value of uy? 4. So write 4 here. Plus, what's the value of ay here? See, this is ay. Ay value is 0.3. So write 0.3. How much time? 10 seconds. So you'll get 4 plus 3. That is again 7 meter per second. What is this? Vy. What is this? Vy. Right? So therefore, we have two components of initial velocity, vx and vy. Yes, yes, Krishna, absolutely correct, right? So this is how we have got the answer. Vx and vy both came out to be 7. So we have, what is the value of velocity being asked? The value of velocity in the question, actually see the question. What is the question asking? The question is asking velocity, or is the question asking about speed? See here, the question is asking speed, not velocity. So you will write speed is nothing but magnitude of velocity, right? So write the velocity here. You will have v is equal to vx I cap plus vy j cap, or even more simply, v is equal to 7 I cap plus 7 j cap, which is magnitude of v or speed will be given as under root of 7 square plus 7 square. We just learned, right? So answer comes out as 7 root 2. So kindly note this down with yourself, everyone, in case you haven't yet. Class, after you do, we'll proceed to the next question. We had initial velocity and acceleration given. We split it into in terms of its components and then accordingly got the answer, right? Yes, Atul, tell me.
So why can't we find the magnitude of velocity and acceleration separately and put it in the equation v equals to u plus at?
Yeah, that is what we have done, right? We have taken v is equal to u plus at, just that we have taken it separately for x and y directions. See, we have taken the formula v is equal to u plus at and v is equal to u plus at. Just that we are doing it for the x side and y side separately, and then we are grouping them up together again to give the vector v. Are you clear,
No,
Atul?
so I was no, so I was telling that if we will find the initial velocity by under root x square component plus y square component, then Then similarly, we will find the acceleration and put it in the equation v equals to u plus at.
Right. So try doing that. If that gives you the answer, you can go ahead with it. No worries. I'm telling you the standard way, right? The way we solved here. See, the way we solved here in terms of splitting the entire vector in terms of x component and y component, and then dealing with them separately and then grouping back together. So this is basically the conventional strategy of solving any vector related questions to kinematics. So just trying to make sure you all are comfortable with this technique. If the other technique is yielding you the answer every time, like don't just depend it on it just in one answer. Take 5 or 6 such questions from past years, or maybe if some book you're following, if you're getting this answer correct by the approach which you just told, maybe you can go ahead with the same, right, Atul? So I'll unmute you. Yeah, let me know. Is my point clear?
Yes, sir. Yes,
Right, try going by it and try doing it with many such questions. If every question gives you the right answer, maybe you can proceed with it, right?
yes, sir.
Otherwise, this will remain the conventional technique which you can always follow, and you'll always get the right answer, at least as far as this technique is concerned, right? All right. Anything else, Atul, you would like to ask or inquire about this question? Let me know. Yeah,
No, sir. No, sir.
clear, right? Okay, right.
Yes, sir.
All right. Thank you, Atul. So, class, let's go on to the next question. Just a minute, class. So class, let's take a short break from 10:20 to 10:25. Let's be back in 5 minutes and then restart the session, right? All right, class. Thank you. Please, let's take a break for 5 minutes and then join back at 10:25. Thank you.